Yeah, thanks for inviting me once again. Thanks for the introduction. My topic today is my research topic here is sentiment analysis of cybersecurity topics on Twitter and Reddit. And so just to give some brief introduction, just general context on how I came about this research is there's a lot of data being generated on everywhere. As we know, last year, 2020, we generated about 59 zettabytes of data, or 1 trillion gigabytes. That's a lot of data in just 2020 alone, and it's exponentially growing. It's always getting bigger and bigger, simply because we have a lot of sensors. Everything is generating data, right? So because we have so much data, there's a lot of intelligence being gathered. And because of that, there's a lot of AI integration. There was a McKinsey survey not too long ago, and it talked about 56% of the organizations are now adopting AI. That means any form of AI, NLP, machine learning, deep learning, that kind of stuff. Most of the AI adoption right now is being done at a customer service level, but still the adoption rate is very, very high. One of the context of AI adoption is due to a SOC MINT, or social media intelligence. It's just because there's so much publicly available data that you're able to find a lot of intelligence. So it's a new field, SOC MIT. And the reason I'm talking about this is because my research is kind of based on these SOC MINT or SOC MENT concepts and the availability of data, right? The data has been used to find some descriptive or inferential or even prescriptive intelligence, meaning you could do a lot of different things. You can understand what's the context of the topic, which we should do about, and what are some of the predictive attributes of it, right? So that's just to be a little bit of context on how I got to do this research. So now we have data. So leveraging NLP techniques is important. There's a lot of good techniques out there. So the idea behind it is you have data, and then you have these NLP algorithms that's online now or available now. And I want to assess the efficacy of the algorithms as well. And for that, I felt sentiment analysis is one of the better way to understand the data. Now, sentiment analysis has been done in different fields, marketing, just in general, but it hadn't been done in cybersecurity sector. So just to give you some context, cybersecurity is my field, is the area of research that I've put a lot of focus on. So cybersecurity is also a very, very high profile and sensitive sector, meaning there's every day we see different different news, different positioning, different threats and all of that stuff, right? So, but sentiment analysis in this sector, in the cybersecurity sector, hasn't been done before. It's been done in marketing, it's been done in finance and that kind of stuff, but not in cybersecurity. So that was one of the reasons why using data and NLP techniques in this sector was so important. Just to kind of briefly go over what literature says about sentiment analysis, is just find emotional tone of the content, or in other words, opinion, what it really means. And generally, it is considered a classification problem in AI or NLP, simply because you're trying to find essence of what the author is trying to say. And in that context, what does that mean? Is the author very positive or negative or neutral? And as they call in NLP, it's called polarity classification, right? Classification problem with NLP is quite complex because we all have different writing style. There's a lot of web tags. We use a lot of different lingos. The document structure and different noises, right? So it's actually quite advanced or quite complicated field. Literature also defines sentiment analysis of a content at a 3 different level. You could do sentiment analysis for the entire document. You could do it for specific sentences, right? Or you could just find like just to kind of see if people like or dislike certain areas, right? So there's different ways to do. So generally we see two different approaches for sentiment analysis. One's lexicon-based, dictionary and corpus, and the other one is just using machine learning classifiers, different algorithms, supervised or unsupervised techniques to kind of see what it means when someone writes or produces some content, right? In that whole domain, VADER, Valence Available Dictionary for E-Sentiment Reasoning, is a lexicon-based sentiment analysis tool that's by Hutto and Gilbert. It came about 8 years ago, 2014. It's dictionary-based. It gathers words without any context and gives priority score. So, it has predefined numerical assignment or polarity score for different words, right? And it also uses corpus-based context where, it uses different stats and, predictive, mathematical assignment of what a score or text means, right? So why are we talking about VADER? VADER is supposed to be quite potent. It's supposed to be actually quite impressive of an algorithm. It's only about, like I said, 8 years old. So there was a lot of interest from my part to see what are some of the applications of this algorithm, right? There are other ones as well, TextBA, Spacey. There's always some libraries out there that you can find. VADER performs very, very well historically through literature review. It has a very high accuracy and it is very impressive and easy to implement. I'll go more on the ease of use a little later, right? Some of the applications we see of sentiment analysis is mostly on the election prediction, election opinion about it, stock analysis. Although the accuracy doesn't seem that impressive, but it's also always there's been a lot of literature, a lot of research on trying to predict stock prices based on how people are thinking on the sentiment analysis, right? There's one particular research that I found it very, very interesting was um, uh, about using political tweets to find a certain party's performance and then how they are gauged about their popularity, right? When we do sentiment analysis, we also find a lot of different techniques, especially in data pre-processing. They talk about removing noise, normalizing, removing stop words, a lot of standard stuff. So there's a lot of different techniques that's been applied, right? So obviously, like I said, when I started, there was a lot of data. There was a lot of data in social media, SOC MIT. But I found these are 4 specific gaps that I found that could be advanced or that could be used in sentiment analysis domain 1. Sentiment analysis in cybersecurity as an industry hadn't been done before. So that was one gap I figured that could be investigated. Twitter sentiment analysis is quite common. You see a lot of literature on that, a lot of research on that, but Reddit has not been investigated. Reddit had no record of being investigated. And if you follow like financial market, if you follow a lot of online data, Reddit has come about as a very important blog that's been making a lot of noise, especially in financial sector last year when there was a lot of stock tips, a lot of promotion about companies. Reddit was quite popular, but Reddit hadn't been used. The data from Reddit hadn't been used to be investigated from an NLP point of view, right? VADER had a lot of popularity for as an NLP a tool, but efficacy of VADER wasn't really tested with human classification. And what I mean by human classification is you have VADER as a classification tool, and then that data hadn't been compared with human annotated data or human labeled data, right? To see if it kind of went, if it was correlated or if it was in parallel with how humans think. So that was one gap that I noticed. And the other fourth one was pre-processing of data. Was that really impactful? Like I said, there's a lot of tags, a lot of a URL, a lot of content that people put when posting data online. You use your emoticon, emojis, that kind of stuff. Was that really important in assessing the polarity of score? So these were more or less 4 different research gaps that I found that was worth investigating, and I'll talk more about that in the next few slides. So then the research question for me became just to, number one, just to understand sentiment of cybersecurity content posted on Twitter and Reddit in a given time frame. So it was important to kind of specify the time frame, because obviously data is always available. That's our premise, but we had to pick a certain time frame. The second research question then became the extension of first one is without text pre-processing, was it a big difference, right? The third was more of a descriptive analysis to find what are some of the things that people were talking about on Reddit and Twitter. And I looked at it as more of an entity, meaning a company. Was it the company? Was it the government? Was it a certain regulatory policies, that kind of stuff, right? And the fourth one or third one is to evaluate the VADER against human classification. And I'll go more about that and how I kind of prepared the method on that one, right? So this is just a visual representation of the method that I used. So I curated 2 different databases or data sets. So the first one, I used a API to grab data from the Reddit on specific criteria. As my paper will describe what were those criteria, certain hashtags, certain popularity, that kind of stuff. And then I used the Python text preprocessor, which I created myself, and it talks about eliminating like URLs, tags, that kind of stuff. And then it was assessed through lexicon-based VADER. And then it classified if it was a positive, negative, and neutral. So the first part was just simply grabbing the data, assessing with VADER, and then you having a polarity score of some sort, right? And likewise, same thing with Twitter as well. At the bottom, use a Tweety API. There are a lot of APIs that are able to grab data from Twitter. There are Twint, Essence Scrape. There's a lot of available, but Tweety is authorized Twitter enabled API. So that one of the reason I wanted to use that was legitimacy of the API, right? So we had 2 different data sets from Reddit and Twitter. And I did a random sampling of tweets from both Reddit and Twitter. And then I found 20 labelers, manual labelers, and they, without the context, would label the tweets. So each person would get 10 Reddit posts or 10 Reddit contents, and then 10 Reddit tweets. And then they would label it in 3 different criteria. If they found it neutral or positive or negative, right? And I evaluated that human classification versus how VADER classified. So I'll talk more about the results later, but this is just a general framework. The idea was to make it modular. So if you wanted to use the same model or framework for a different sector, that would be possible, right? So it wasn't really specific to cybersecurity. Cybersecurity was just a context for me, but you could use this for any sector, and it's very specific on what are some of the things you should do, good practices, and that kind of stuff, right? The pre-processing, just an idea, just I'm talking about this, something that was integrated in the model. The first is you extract the raw data, you remove noises, you normalize it, you ensure that it's in a certain lower cases or that kind of stuff. And then you remove stop words that are not important. And then you stem and lematize it, right? So these are what literature calls a good practice to have really clean data to be able to do sentiment analysis. This is just an extension of the other one. This talks about not pre-processing. So remember, we wanted to see if pre-processing really made a big impact on sentiment analysis, right? And our evaluation was really standard. The first one was to measure polarity, like, if it's positive, negative, neutral. Sorry, there's a typo there, but um, just to see where it stands. And there's no right or wrong. It's just the way the algorithm talks about, right? The second part is to evaluate the algorithm, meaning its performance against human classification. Now, human classification is supposed to be basis or source of truth. We assume that human classification is right, always right, and then we see if the VADER algorithm can kind of mimic the human classification, right? Because the premise here is humans classify sentiments better than the machines or algorithms, at least at this point, right? Standard evaluation metrics is nothing new. I'm not going to go through that, but accuracy, precision, recall, these are all the combination of scores that we can use for classification problems to ensure to measure the performance, how well or how badly it is doing, right? So the first one, research question to understand the sentiment of cybersecurity content posted on Twitter and Reddit in a given time frame for pre-processed data. And I'm just going to remind you that cybersecurity, as a researcher in this field, we find a lot of negative sentiment. That's the standing premise that we have, that cybersecurity is viewed as a cynical sector, is viewed as a sector that has a lot of mistrust, that are a lot of people not really thinking it's a good thing, right? That's the premise. Generally, we think of cybersecurity, at least from a researcher's point of view, or industry point of view, that people don't have a lot of confidence in cybersecurity, right? But as if you look at the observations, we found 32,000 lines of tweets regarding that specific criteria about cybersecurity on Twitter, and so a base polarity talks about like this is standard, very specific. Moderate is we increase the threshold, so it has to be really really positive or really really not negative. And the extreme polarity is like extremely negative or extremely positive. And for Twitter, we had 32,000 observations within that 1 week time frame that we collected data. In Reddit, there was about 1,200. Again, Reddit isn't as prolific as Twitter because it's mostly blog posts. People talk about discussions and kind of stuff. Where Twitter, people just can tweet quite frequently, right? One point to remember is those observations were cleaned up of any missing data. So those are really clean content. So just not to go through each and every number, but the essence here is there's highly positive um, um, uh, polarity for people on both Twitter and Reddit. Remember, we thought it would be quite negative. No, it wasn't. Mostly positive contents was posted on cybersecurity topics on Twitter and Reddit. And then there are a lot of neutral topics, neutral contents, and negative. So negative was actually second. So in the best case, only 22% of the people were negative for base polarity, and extreme negative contents were very very less. On Twitter, it was about less than 2%, and then Reddit, it was about 0.5%, right? That was for pre-processed data. And we wanted to see also if pre-processing without pre-processing, if it would impact the polarity score. And the numbers are quite plentiful on the screen, but essentially what I'm going to say is it didn't really make a big difference, to be honest. The scores were very in line. There was a delta of percent or two, but for the regular eyes, it didn't really make a difference if it was pre-processed or not. So the framework could technically not pre-process the data, not pre-process. I mean, pre-processing takes a lot of resource as well. So if it didn't pre-process, it wouldn't really have a drastic changes or drastic difference for the data, right? Some of the entities that people were constantly talking about on the data we have was on Reddit, people were talking about a lot about Facebook, YouTube, Firefox, Apple, Microsoft, UK, the United Kingdom, and YubiKey. And on Twitter, people, again, see similar, they're either talking about technology or country, and also GDPR. GDPR was a consistent theme. It's a data protection regulation. So one thing to note that is obviously with the social media data, it's quite dynamic, meaning that any um, any any uh, any hot topic or flavor of the month gets more hits or more tweets or more Reddit posts, depending on where you read. But it's just to understand what was the essence at that given period of the time, right? So the method I talked about earlier, so we took random sampling of tweets and Reddits, and then we gave it to human labelers, and there were 20 of them, all of them from cybersecurity domain, so they knew what the tweets or Reddit posts were more or less talking about. They had some context about cybersecurity. For the Twitter random sampling, um, since it was a negative sampling, sorry, it was a random sampling. Um, there was 9 positive and 1 negative tweets, so it was not directly selected. So it was random sampling. So there's no way to control what kind of there was not an equal distribution of labelers, right? So um, the Twitter the VADER algorithm was quite consistent in finding the positive accuracy. So whenever it was a positive tweet, it was highly accurate. That's what I'm deducing from the observations here. And for the Reddit, same thing. It was all positive contents. So it was highly accurate when it goes to positive, right? So the key takeaways I found from the research was obviously it was dominated quite heavily by the positive sentiment, positive polarity score. People were largely talking about a lot of positive stuff. They had a positive state of mind. On Twitter, Reddit was kind of less positive. It was 27%, but still Twitter and Reddit outweighed the negative sentiments across both platforms. So people were largely positive more than negative. Negative was kind of like distant third. When compared to human classification, which was considered a standard or source of truth, VADER produced 60% accuracy for Twitter and 70% for Reddit in assessing the sentiment. So, in other words, VADER didn't really didn't look like very expressive or very effective algorithm given a very small sample size, right? VADER we found was quite weak in assessing negative sentiments. And the other thing was we found out the research, the framework could be modular. So essentially with just few line of codes, you could kind of transfer the research framework or research stance to a different sector, right? So the modularity was kind of like a key takeaway that it is possible. It is possible to apply this in different sector, right? Excuse me, just one second. So some of the limitations, obviously, it's quite glaring, is we cannot deduce or we cannot say VADER is a bad or good algorithm because our sample size was quite small and it makes it very unconvincing because obviously X number of tweets from a bigger sample size is not just enough. That's what we found out. And the challenge here is to finding people who know about cybersecurity to manually label it. Like my survey for our human labelers were 20 people, and that's quite a lot of people to have it committed to label it, right? And you cannot give like thousands of tweets to people to regulate it. It's just impossible. So you have to kind of pick a fairly small number, and the challenge there becomes that that fairly small number cannot really give you a bigger picture. The other aspect of it is social media is unregulated. People can stuff, put a lot of stuff, but and when I'm curating this data set, uh, how do you detect fake data or bots or just to like, you know, bots that constantly promote some entity or technology? How do you regulate that? That's a difficult one that needs another layer of pre-processing, so to speak, right? So in the future, it needs to be key parameter to be resolved. Yes, social media is great for a lot of data, but it's also is it good data? And then volume, like, you know, the context about big data has always been about a lot of data. Now we've kind of shifted away from a lot of data to quality data. Now that quality of data is not incorporated in this research, right? Because we're just kind of taking um, um, the tweets or whatever it is, and it's just looking at it from a data presence point of view, meaning if there's entry, then we accept the data. If there's no entries on certain columns, we don't accept the data, right? So that's one thing that can be fairly improved. Data was also collected in a very short duration, less than a week. The 32,000 and 1,200 posts were collected in a very short period of time, maybe extending it to maybe a couple of weeks or months. That we don't know what the exact timeline would be good. Would create a better preview, right, or better sample size of the context and what people are talking about. So these are the limitations. The limitations make the research quite challenging. But the whole idea here was to create some sort of modular framework, and then have an idea, have a system that can be implemented across different technology, and also kind of test the efficacy of VADER, which is leading sentiment analysis algorithm out there. Literature is quite consistent with it being the most effective algorithm. So that was one of the areas what I wanted to test. So that's it. That's all I have. It's just a pretty straightforward research topic, and I will be taking questions if you have any.